There is a practice exam that most of you have not. There's one person that's done it. Before you take the test, you need to try out that practice exam to get a hold of the Respondus browser. I don't want you going into the Respondus browser the first time and trying out to do the test. That is not a good idea. Do not do that. That's just like, that's just asking for trouble and asking to not get a good grade on your test.
So we weren't supposed to use the Respondus browser for the practice test?
You should have. That was the purpose of it.
Oh, sorry.
I think you were the one that took it, right?
Yeah, I wasn't able to upload the scanning since I couldn't access my email.
Yeah, that's fine. The main thing is that like we use it to be monitored. I guess is that there's some kind of video of you taking the test.
Use it on my iPad. Is that okay?
You should be able to use it on your iPad.
All right.
It's a separate little option, and they make me click it off. But I clicked it off. If it ever tells you you can't use an iPad, let me know. But it should not. Like it should all be good to use an iPad. Chromebooks aren't compatible, so if you cannot get into Respondus, you can always come. I will be in here in the Zoom classroom during the test, and we can work something out in the Zoom classroom. If you take it and you take it on the thing, if you take it through Respondus and you can't submit it through Blackboard, because it's a bit of an odd sort of process. So what you have to do is you have to take the test through Respondus and send it to yourself. And then you have to go back in, and you have to go back in under a regular browser and upload it into Blackboard with a regular browser, I believe. Yes, for the practice exam, for the exam and for the practice exam, you have to use Respondus lockdown browser. That's the purpose of the practice exam, so that you're not using it for the first time on a graded assignment. So I need y'all to try out the practice exam. Try to get Respondus working. Well, if it's not going to work in your Chromebook, then I guess you're not going to do the practice exam. I don't know. Then you're not going to be able to do it. Then you have to come. The practice exam is there just to basically make sure you can do it, that you have control of Respondus and you know how to get into Respondus. So if it's not going to work on your Chromebook, I mean, you can try it if you want, but if you already know it's not going to work, then it's not going to work. And so we've done chapter 1 was logic, and now we're into chapter 10. We have 2 sections in geometry. I don't know. I don't know how to say it, but I'm like really worried about these classes because this is like some of the most quiet I've ever had students. Like, I'll ask a question and it'll just be like a few minutes before I even get a response. I need y'all to be more active, and this is like both classes are doing this. I need y'all to be more active in everything that we're doing in this class.
Sorry, I was just waiting.
No, I mean, it's not everyone, right? And so I think some people are doing what they're supposed to for the most part. But even like the people that are doing what they're supposed to, I think y'all can be a little bit more active too. I'm not trying to put this all on you, I guess is what I'm saying. But there are some people that just aren't doing anything. They're not doing what they're supposed to for this class. And I feel a little bit better about this class, to be honest, because I have 26 students here. But my other class, I have 14 students in it and 7 students showed up. And it's like, this is the class before your first test. Like, why? I don't baffles me. Like, why would you not show up to that class? Like, that is not smart. Like, you're just asking to fail the class at that point. And that's half the students in my class. Like, that's really kind of alarming. This class, a lot more of you are here, but a lot of you aren't doing the class. I don't know how to say it. You're not watching the video, and I can see it in the video views. Like they're going down, and like I don't know what to do because you have to go and watch the videos for the class, and that probably explains why class is going so slow as it's going. Like we should be going at a little bit quicker pace for these lectures. Like I don't know how else to say it, but like there's no reason we should be going as slow as we're going on some of these problems. If you have and you've watched the video, you should know a little bit about what's going on in class. It should be going a little quicker. And a big part of that is I think that people aren't watching the lectures now. It got worse and worse as the lecture views went down. Like you've got to prepare for class. It's something that's going to be expected in most of your college classes. It may not be expected in a lot of like the science classes, maybe. It might be a little bit different for a science class, but like for the most part, like you're gonna have to go home. You're gonna have to go home on your own, and you're gonna have to read something and try to come up with a comprehension of it. And then you come into the class and you have a group discussion. That's usually what sort of happens in college classes. But the emphasis is that you're doing work on your own, sort of, and that you take some sort of initiative in your own education. And like I can tell you like why math is the best. I can tell you why it would make your life better. I can tell you like all these sorts of things to like try to cheerlead you on, but like whew. But yeah, I don't know. I'm kind of debating what I need to do for these classes, I guess is what I'm saying. Whether I need to flip them back around and do the lecture in class and then assign homework. But that like I'm trying to like be kind of, I don't know how to say it, but like I'm trying to be kind of generous and like give you like class time, have the lecture pre-recorded, and then you have class time. It saves you work doing the class structure this way.
Yeah, for me, it's more helpful doing homework in class because I can ask. It feels like less of an interruption to ask questions.
Yeah, and if you have a
Yeah.
question, you can always ask me before you have to submit an assignment or something like that. It gives you a little buffer there. And I really don't want to flip the class structure. But like if nobody's watching the lectures, I don't know. Like, I mean, I don't know if it's like, and I don't want to say it, but like, I don't know if it's like the high school mentality coming through or what, but like, and that's a generalization, so don't take that. You know, some adults don't get it, you know, and some students, high school students, really get it, and you know, so there are exceptions, but like I don't know if it's just the way that you're used to learning or what it is, you know. But you've got to watch the lectures, and we've got to be getting through this stuff a little bit quicker, I guess is what I'm trying to say. And I'll admit, like chapter 1 is a bit different. So if it intimidated you because it was logic or something, we're going to be doing a little bit different stuff from now on. Subject matters will change. So if you don't like a certain subject matter, it may not be on the next one, or maybe on the next. Unit analysis we use over and over again. So I guess learn to like that one. I don't know what to say, but this is 32. We want to convert the degrees, which are in decimals, to minutes in seconds. So again, there are 60 minutes in 1 degree. There are 60 seconds in 1 minute. And so then we have to think about how to type it in. We have to use a degree sign for degrees. We use 1 tick mark for minutes. We use 2 tick marks for seconds, or apostrophes, I guess you could call them. And then pray to the formatting gods I did the format right. I think it should do it whether you do a space or not. So if 1 minute is 60 degrees and, sorry, said that backwards. If 1 degree is 60 minutes and 1 minute is 60 seconds, and we have 32.5 degrees, well, you know you have 32 degrees. How many minutes you got? Mm. $32 degrees, but how many minutes you got? So a whole one is 60. How much does that happen? Do what?
Nothing. I'm not good at converting, so like this was the one thing I had so much trouble with.
Okay. When I was in sixth grade, Miss Thomas taught me this, so I'll say it. If we go from small to big, divide the pig, big to small, multiply all. So this way, we're going from degrees, which are bigger, and we're going from small. So we're going from big to small. There should be some multiplication happening. So multiplying something by 60, if that helps.
Yeah, this was one of the only parts in the lecture that confused me.
And the thing with this is I'm trying to skim past a little bit. I'm trying to give you like some simple rules on this until we get into like the section on unit analysis, because there will be a separate section on unit analysis and we can really kind of go into this a little bit more. All right, I'll give you 30 seconds. All right, so let's see. 3230 is what it should be. What are y'all saying? Degrees? That's not what they asked. 30 degrees, 30 minutes. Oh, y'all wrote it out. Okay, so that's fine. You didn't put a degree sign here, but that's right. That's correct. 3230, that looks right. I don't know why. Never mind. That's the one that did count right. 3230 should be what you're
I think it's just one of those questions where it's like, if it's not word for word, like exactly as the computer said, it wouldn't count it.
Yeah, that's exactly what's happening. And there are other ways to sort of do things on here, but they make you pay money. So if I'm being honest, I think I could probably set it up differently, but I'm not trying to pay them every month for their service. It's not that great. Pull out the whole first. So the first thing we do is pull out the 32 degrees. And this is the thing I was talking about. If we have a half a degree, that's going to be a half times 60 would be 30. So that's where we're getting that 30. So if one of them is 60, half of them would be 30. So what we do is we pull out the whole and then we convert the fraction to the smaller units. And this is the process we're going to use. I think we're going to up it one maybe in the next one. If you tell me 0 minutes, that's also correct. You could put 0 there. But yeah, this is the formatting that it's going to look for on these questions. It's going to be a degree with a degree sign and a minute with the little apostrophe minute sign. I did not do these in Word. All right, same thing here. I'll give you like 30 seconds extra after this thing counts down, I think. But try to get them done. 8, 3.
Question.
Oh yeah, what's up?
How do you put degree sign?
The degree sign? Are you working on your like phone? Usually it's like the little second keyboard.
Yeah, I'm on my my Chromebook. I don't have a degree sign on mine.
Let's see.
There is no
149. If you if you look up the word degree and just copy and paste it, that's one way you can always do it. Or if you just like, I think you might be able to, can you select it on this problem? Sometimes if you copy and paste it, it will, that's one way to get it. If you're on a computer, if you're on your phone, it's like you have to go to the symbols to get it.
I'm putting degree. There you go.
All right. Yeah, and if I'm being honest, like, I shouldn't tell you. I should just keep that to myself right there. Never mind. Okay. I care more that you participate than you get things correct, though, right? It looks like I'm skimming through. It looks like some of you are getting this thing correct, but let's go over it on the next slide. I got it going down. So if we have this, we have the 149 that we're pulling out as a whole. We have the 0.83. This is a fractional amount. So if we multiply 0.83, we get 49.8. And so that is our minutes that we're pulling out. And so if we pull out the minutes, we still have a fractional 0.8 minutes that we're going to convert to seconds. So it's kind of like we're dividing this and we're dividing or multiplying it, and then we're multiplying it again, right? By 60. We're multiplying it twice by 60, basically, is what we're doing to get 48 seconds. So if we multiply by twice by 60 this way, how many times we got to divide? Divide going the other way. That's probably something you want to think about going to this next slide when Quizzes wants to go to the next slide. Oh my God, what's happening? I don't see it. There we go. Convert this to, now we're going from minutes and seconds, and I believe we're converting to degrees. Is that what we're doing? And so we have, this is problem 25. It's 8 degrees, 59 minutes, and 10 seconds. So we want to convert this to a fractional degree. So remember, there are 60 minutes in 1 degree. There are 60 seconds in 1 minute. I will keep that in mind next time I make out my keys for these things. I'll put the word degrees in there if I have to. I do appreciate you telling me. If you do a Google search for the degree symbol, it should come up. If you're on a computer, you just put Control-C, Control-V, copy paste. All right, give you 30 more seconds. So there is that number 59. What are we doing with 59 to convert it to degrees? divide by 60. We divide 59 by 60. We
Right.
divide. What was that?
Oh, I didn't know my mic was still on. I was just saying to myself, I hope I'm doing this right.
You divide by 60, and then what'd you divide the other one by? There's a few ways to do it.
I was trying to divide like the 59. That's minutes, right? 59 minutes.
Yeah, 59 divided by 60, and then we take that 10 and we divide it by, someone's telling me 60 times 60, you're dividing it by 60 twice, right? That's the important thing to remember here. I'm going to divide it by 60 twice. Oh, I didn't answer. Did I? Yeah, I did.
Why are we dividing 10 twice?
It is in seconds. So the first time that we divide it, it is going into minutes. And then the next time we divide it, it's going to degrees. So you have to convert it twice. And each time the factor is 60. So when we went the other way, we multiplied things twice to get to seconds. Now we're dividing twice to get back to degrees. Okay. And it should look something hopefully like this. So we have the 59, we need to divide that by 60. This 10, we're dividing by 60 twice. So you can either hit the divide sign twice, or you can just divide it by what, 3,600 is the same thing. What this basically says is for every 1 degree, there are 3,600 seconds. That's what the word I'm looking for. Okay. Find latitude and longitude. So we're doing antipodal points here. And so the thing about antipodal points, let me pause this and I'll give you all 30 seconds afterwards. If we're looking here, it's kind of like you have a lever with a fulcrum that's like right here at the core of the earth, right? And so if we have a lever, if we think about this thing, if this thing goes up, this side's going to go down, and this side's going to go up exactly as much as this side's going to go down. So as much as this goes down, this is going to go up. So it's going to be vice versa of whatever we do over here, and it's going to be to the same. So this is the 0 degree line. This is my equator. This is my 30 up here, 60, and it goes up to 90 here. It goes down to 90 here. So this is 90 north, this is 90 south. Vice versa over here, when we do meridians, the prime meridian is our 0 line. If we look here, this would be 30. On the other side of 30, I have 150. So the key thing that we took away from this is that they add up to 180. So this is kind of like the same number, but the opposite sign. This one, they both add up to 180. So when I'm looking back here, this should hopefully, I said it, but I'll say it again. Same number, different sign. We have to swap the sign. But if I add the two numbers up, they should add up to 180. So what number in this add up to 180, I guess is what I'm asking.
Wait, I'm sorry. Say that last part again. I didn't quite hear that.
So this is going to be the same number, but kind of the opposite sign, right? This one, they're both going to add up to 180. The other number I want is what number adds up with this to get 180. So it's like we're adding to go that one way to get to 180. If we want to go the other way, it's not the adding. It's the thing that's not the adding. It's the thing we do to undo the adding. All right, give y'all 30 seconds. Okay, so this one is a bit of weird formatting, but it's 44 and 101 is what I'm looking for. And you got to make sure you change the sign. So south and east, I think maybe it's like not counting it right because it needs a degree sign in there or something. But yeah, 44 and no, it'd be 101. So if this, we're going to add up to 180, we have to subtract this from 180, right? It's the other direction. So subtracting 79 from 180 should give you 101. 101 is getting it. 101 is getting it. 101 is getting it. There we go.
So why do you subtract the longitude from 180 rather than latitude? Because the latitude isn't.
So the latitude, if we go up, it's going to go down the same amount. So if I'm going up to 30 north, my line's going to go like down to 30 south. So it's the same number, but it's the different sign. But if I look at my longitude, right? My longitude, the opposite of it, it has to do with the way that like they're drawn. These are concentric sort of circles going around. And so we're never going to hit the other line. This one it hits the other line on the other side. They're not concentric circles. They only go around half the Earth. And so when we get here, when we look at the 30, the thing that's opposite of the 30 is the 150 line. It has to do with the way that they're numbered. So here's 30, here's 30. But if we look at the antipodal of them, our antipodal ones add up to 180. It's basically, long story short, it's the way that they do their graphing system on there, right? It's the orientation of their graphing system.
That makes sense.
And so we have one more about latitude and longitude. This is the last one, but we talked a little bit about how things are numbered. I get them mixed up. Latitude looks like laps. Latitude was the thing that I want to do. It tells you, it looks like laps going left and right, but it measures up and down. So it is latitude that we want to look at here. So if we want to know which is furthest from the North Pole, we want to think about our 0 being our equator, and it goes up until we get to 90 at the South Pole. It goes 90 at the North Pole. 0 is the equator. So which one is farther from the North Pole?
Cape Town, right?
What was that? That was so random.
Transformer.
Yeah, he's got a voice modulation on there. The one that is, which one of these is furthest south, right? Is the same way as asking it, which one's furthest from the North Pole? Which one of those is further south?
Buenos Aires.
Yeah, it's the larger one. So I think it's the next page. So I guess we'll go ahead and answer it. I'll keep the timer on. And why do you say it's the one that's further south? Because it's the larger number that says south on it. If it was north, right, it would be the smaller number, right? I guess that was the way to look at it. The larger north you get, the closer you get to the North Pole. The larger south you get, the further away from the North Pole. Sorry. The
Can you shut
farther
up?
south you get. You know what I'm saying.
Can you stop the timer, please?
It's 30 seconds. Y'all got it. We already talked about it. Oh, wait, this is a different one, huh? Shoot.
Yes, it is.
Oh, man. Didn't notice I was on the next problem already. Sorry. This one, I must have skipped past a page or something. I thought I had one that explained that one. Yes, I did not. Or did I? Was there not like an answer to this thing for this one? I know you already answered that one.
There it is.
I skipped past it, I guess. I
Yeah.
skipped past it and right into the next question, apparently. My bad. So this one is, what would I say? Buenos Aires, because it's a larger south? Is that what we said?
Which is further from the North Pole out of these? Which we just discussed.
Yeah, larger south number. That's the one we want for this one. That's all I'm looking for. I think I'm going to cut this off and end this question. We have talked about this one way too long. Let's get to the next question. Open response. It's fine.
Oh,
I don't think these count in your points. Now, this question. This one, I'm pretty sure I want a number on. So let's look at this. Buffalo, New York, and Miami, Florida, they are at the same longitude, but different latitudes. And they talked about this, like we can measure 1 degree of latitude and it's like 69.4. But if you look at the way longitude is, like when you get closer to the pole, the longitudes are closer together, right? And when you get further from the pole, they're further apart. So we can't actually measure 1 degree when we talk about the other guys, but we can when we talk about north or south, and they are approximately the same. We know one's at 43 and we know one's at 26. So how many degrees apart are those guys? And then if 1 degree is 69.4 miles, how many miles is that going to be? So there are seemingly 2 operations in here, I think. So we want to know how many degrees apart these things are. And after we know how many degrees apart, this is like you're buying 9 apples and they're 10 cents an apple. What are you doing to those 2 numbers? How do we figure out how many miles there are? If each degree is 69.4 miles, and we know there are so many degrees, ooh, I almost said that out loud. Okay. I'll give you about 30 more seconds. No. Okay. So I think I have this broken apart in another slide. $1179.8. Oh, did I not put miles in there? It should say miles. So I don't know if I got it right or wrong. I got the right jingle. Oh, someone. This was not the way to say.
Before you told us it was a number and it was the new question, I was like,
Yeah.
I gotta type something.
My fault. Okay. Come on. Show me your responses. 179.8. It looks like some of you are saying 1200. I think you'll probably round it or something, huh? 1200. Okay. You either rounded or you probably looked at the back of the book or something.
Wait, so how many miles is each degree? Sorry.
Each degree, we're going to go over it in just a second. It'll be right here. 69.4, I believe. 43 and 26. So we want to know the difference between those things, right? We want to know how far apart they are. We take the difference. And then we take that difference. We got 17 degrees that we want to talk about, and we multiply that by the 69.4. It should give me 1179.8. Questions about this? And we will go more into this when we do like unit analysis. But if you look here, I can always put the 17 in whole numbers. I can always put them over the number 1, right? So if you want to put this over 1, we've got a degree up here, which would simplify with the degree down here would be in the unit of miles. So we will go more into that when we do unit analysis. But we should be multiplying here. Walking around the sun. So this is that physical difference, physical size versus angular size, weird thing that they sort of do. How does it look from my perspective versus the actual size of the object, right? So they created some sort of ratio. This is the problem. The sun has an angular diameter of 0.5 degrees when you view it from the Earth, and a distance of 150 million kilometers. And they want to know the diameter of the sun. So the formula they give us in here is not set up to find the physical size of the object. That's what they're asking. They want to know the true diameter. And so if we wanted to solve this, and we wanted to solve this equation for physical size, it's being multiplied by this crazy thing, or this fraction. There are a few ways to do it, but if we want to get physical size by itself, what do we have to do with this thing over here? What's not multiplying?
Divide.
Dividing it. Yeah, so dividing it, it's the not multiplication. The undo the multiplication operation. Inverses is what they call them. We're dividing by that 362 pi. Do you know what happens when you divide by fractions?
It turns into a whole number, doesn't it? Or something like that?
We change this operation, and what do we do with this thing? Dividing by 2 is the same thing as multiplying by a half, right? It's like the flips. Someone said
Yeah.
flips. So we got to flip this thing and change it to multiplication. The other thing you can think about reciprocals, right? If you just like multiply by the reciprocal, this top line, we end up with this bottom line down here. This becomes a big fancy one. All right, so this is the formula that we actually want to use. And I think they derive it in the book even. So this is a formula that we're probably going to want to use for this problem. So I think everything else is just plugging in information and making sure you plug it in correct into that formula. Making sure you do maybe some PEMDAS in the right order. So I will work through this. Let's see what it says. I got the formula there. Oh, come on, sync up. My phone goes to sleep and then it gets out of sync. So physical size is equal to angular size times 2 pi times distance over 360. So angular size, there is one number there that is an angle. Distance, there is one number there that is a distance. For pi, you should use 3.14. And I want you to plug things in. I want you to realize that this says 150 million. So for millions, we're adding what? Six decimals or 6 zeros to there. 1, 2, 3, 4, 5, 6. Oh man, I think I might have messed up when I put in this answer. I don't think there's any commas in this one. See if I remember how I put in this one. So the angular is 0.5. That's the amount of degrees it is. That there's, if you know how to convert
For
it.
the answer, for the
What?
answer, should we round up?
For the answer,
'Cause I got a pretty long.
I think I rounded to the nearest whole number.
Okay.
God, this is a good question. I don't remember, to be honest. I think I rounded to the nearest whole number on this one. But if not, I rounded to 2 decimal places. I feel like the nearest whole number, and I feel like I forgot to put commas on this one. Although I could be wrong on that too. I think I'm going to throw commas in there and see if it counts it right. Well, it helps if I do them in the right spot. 3. And the units here, what should our units be? I don't know if I put them in there or not. We want to know the size of the sun. If the distance is measured in kilometers, what is our size going to be? Should also be in kilometers. All right, I'll give y'all a few more seconds to plug that thing in. Oh man, am I gonna get a ching ching or a womp womp? Okay, I managed to get something correct. All right, some people rounded it 1.3 times 10 to the 6th. Is that what your calculator told you, maybe? 130833, that is the right number that you should be getting out of there. 8. That one looks a little high, maybe you rounded. I would probably give you that. That's close enough. 130833 looks good. It should be around somewhere around 130833. And so that's the diameter of what, the sun?
Yeah, I just abbreviated, like did the whole like 1 point and then like 3 numbers.
Who was there was a Greek mathematician that did the diameter of the Earth, and he did it really, really close. Eratosthenes. If you ever want to look up this guy and how he did it, he looked at a light going down a well at one point, and then he looked at light going down a well, and he used, I believe, the Pythagorean theorem to prove or to demonstrate like the actual diameter of the Earth. And this is ancient Greece. Like, you know, there's that notion that people thought the Earth was flat, and it was fairly popular, but there's always been a sect of people that knew the Earth was round. Let's just put it that way, right? And he was one of them. Like, there were people that knew it, right? It may not have been popular, but there were still people that knew it before it was a recognized sort of fact. So this, we got a railroad track with 3% grade or a slope of 1 in 25. So the book gives us, where they give us pitch, grade, and slope, and they're all pretty much kind of talking about the same thing. So what we want to do here is we have a 3% and we have a 1 in 25. And so they want to know which one is steeper, and so this is like your slope, right? The larger my slope is, the steeper it goes. The larger positive, the steeper it goes up. The larger negative, the steeper it goes down. So this one is asking pretty much which one is larger. Which one's steeper is kind of synonymous with saying which one of those is larger. So you might have to convert them. This is comparing fractions, right? You could do the butterfly if you want to do it. I'm going to do the little butterflies. But this is comparing two fractions, seeing which one is larger, basically, is what we're doing. Personally, I would convert the other one, probably. It's really kind of easy to convert if you just think about it for a little bit. I'll give you 30 seconds. 30 on the clock. All right. That's 30 internal mental seconds, so who knows? Got to think about something that's 120 beats per minute. Next slide. What are we getting? Oh, never mind. It's a multiple choice. That's right. So it should be the 1 in 25. So I think the easier way is just to think about this as a percentage. 1 in 25 is going to give me 4 out of 100 or 4%. 4 is bigger than 3. The other way is to do 3 out of 100, and maybe you could do some butterflies. You'd get 75 over here. You'd get 100 over here if you did your little butterflies. 100 would be bigger than the 75. So this is comparing two fractions. This next one, they're going to ask us for a slope on an 8 and 12 pitch. And so the slope, so the pitch, they say blank and blank, right? And then like for the grade, they give you a percentage. And then for the slope, we actually want the fraction, right? And if you give me a fraction in a math class, you should really make sure that fraction is reduced. Make sure your fraction is reduced, okay? Or you can round to 2 decimal places. Usually if we're doing things in like pure math, we really like those fractions because they're exact. But then when you get into like reality with telling people money and stuff, right, we're gonna have to round it. So depends what we're asking for sometimes. But 8 and 12, I'll give you 30 seconds. What is that? That has a slope. All right, so eight and 12, that's 8 divided by 12. If we reduce that, that should be 2 divided by 3. So if you told me something like what, 0.66 repeating, or something like 0.67 or 2 and 3. All right, look at that. 15 of y'all got it correct. That's looking pretty good. Sorry for that odd noise. I will try to make them more sporadic in the future. How does a roof rise in 15 horizontal feet? So this, we know it's 2 to 3. 2 rise to 3 run. They want to know the rise. They're giving you a run. So if you want to write equivalent fractions, that might be one way to do it. There are a few ways to do this one. That's the glory of math. There are a few ways. You can put all your own personal little biases in there if you want. But if we run 15 feet, what is the rise? And there's a 2/3 slope. All right, give y'all 30 seconds. Okay. So what is it going to rise if we go 15 out and we got a... Did I get it wrong because I didn't put my units on there? Maybe. It's what, feet? 10 feet. All right, so the next slide, I go into that a little bit with this next slide. And so this was what I was kind of sort of talking about. If we go 2 rise to every 3 run, that is the slope that we figured out, the 2/3 slope. What is my rise going to be if I'm doing 15 run? And so you could do maybe some cross multiplying. You can multiply the 15 over. That's another way to do it. But if we do cross multiplying, you get something like 3x equals 30, right? Our x would be 10 then. Or if you want to think of these are equivalent fractions, if we multiply the bottom by 5, we also have to multiply the top by 5. So there are a few different paths. A few of them are correct. A few of them are wrong. So.
Is it just a rule that it's 2/3?
This is what we got from the previous problem.
Okay.
That was the slope from the 8 and 12, or what I think is what they told us, right?
Okay.
There's like a part A and a part B, and it's the same problem, I think. And so we get the solution from part A was 2/3, and then they tell us if the run is 15, what is it going to be a rise? Okay, so this is the thing. This is as the crow flies example, but this one, I believe, is the walking one, right? First, we're going to walk the blocks. And you get it big. There we go. And each one of these is 1/8. And so for this one, we're going from the bus stop to the library. So they want to know, what's the distance we're going from the bus stop to the library if we have to walk on the streets? So the first part is like the walk on the streets. And then I believe the second part is the flying across the buildings part. Flying like a crow. As the crow flies is what the book says. Yeah. Okay. Put this out of the way. All right, I'll give y'all 30 seconds. Is that fair? Mute, huh? Here we go. Okay. So we go 6 blocks one way, we go 1 block the other way. How far is that? I think I hope I have an explanation. I think there's an explanation on the next page. Yeah, there is. I remember. Should be 0.95 miles. What are y'all getting? 0.95. Okay. I forgot your decimal place, but there you go. 0.75. I believe that gives you the 6/8. I think you missed a block if you did that. We're going 6 blocks up this way, so that's 6/8. And then we have to go up 1 block this way to get there. That's another 1/5 of a mile. So we're adding an 8 6 times, or we can do what? 6 times 1/8, so we can do 6/8. So we do 6/8, and 1 more 1/5 is going to give us 0.95 miles. Any questions about this one? Anybody?
I'm just gonna be honest, I thought we're still on fractions.
Do what now?
I put mine in a fraction.
Oh, in a fraction.
I think a lot of other people did that too. I saw a lot when you're scrolling through it.
0.95. That would give you what, 19/20ths?
Yeah, that's what everyone put in their things.
Yeah, okay. Yeah, that's correct. I probably didn't put that in there, so. Yeah, that'd be 19/20ths of a mile. That's fine. So now I think we're doing as the crow flies. So what formula are we going to use to figure this thing out? What was that cult? There's an entire cult developed around. There we go. Pythagorean, someone said it. So Pythagorean theorem. So then you're going to have to do some sort of triangle, I think is what we're going to have to do if we're going to do Pythagorean. Have to figure out the lengths of those legs. A squared plus B squared equals C squared. I feel like most of you could just probably wake up from a dream and just like cite that and like not even know where it came from, but probably just say it in your sleep. If I asked you to give me a math formula, that's probably the formula people would give me.
That's
Either
the
that
one
or
everyone knows off the top of their head.
Yeah, either that or E equals MC squared, right? It's going to be one of those two. They're good formulas. Who knows?
Fun little story. My family does trivia every day at dinner, and this was actually one of the questions. It's like, what is the formula for finding a triangle? And I was like, I got this, no problem.
Yeah, the Pythagoreans are really weird. There's a whole group of them. They believe some pretty interesting stuff. They believed a bunch of hokey numerology stuff too. So, but there's that myth that like they went out in the boat, and the guy proposed that irrational numbers exist.
Yeah, and then they threw him off the boat.
Yeah, he didn't come back. It's really weird. Like people get really, I don't know, defensive or something. So 2 decimal places is what we should hopefully be rounding this thing to. Doing some Pythagorean theorem on this guy. Make a triangle, try to figure out the straight distance between them. All right, so I'll give y'all 30 more seconds, something like that. Is this y'all submitted, right? It's just not loading it up. I hope so. Hope I ain't the only one. Woo, okay, that's better. I was like, Square root. Oh yeah, you gotta square root it. So I think I have a slide that goes over this. Let me see. Now I'm gonna back it up. Oh, I'll just pause this one. Here we go. It's the same picture, different question. But if we're looking at these things, this one is 6/8 and this one is 1/5. I have to do 6/8 squared. Oh, I mean, let me pull up a word and do it. .78. Still give it to you for 0.78. I guess I'll do this. Did I not? I could have swore like I had a slide that like said this. Am I just like missing slides? Am I skipping ahead? Oh, I guess I didn't. Am I sharing the right thing? Okay. All right, so we want to do 6/8 squared, and we want to do what? 1/5 squared. And then after we do this, and if we add them together, what are we going to do after we do add them together? The last thing is to what? Square root them. And so it should look something like this. And so the first thing is to take 6/8 and square it. Take 1/5, you square it, and then you add those two together. And then the last step should be to square root them. And then this question, it says, how many shortest possible paths are there from the bus stop to the library? So you want to count every path. Oh man. They didn't do well on this one last class. I'm not sure. This is a bit of an odd question, if I'm being honest, but I think it's doable if you just kind of look at it and try to reason it a little bit. I don't have the quizzes shared, do I? Here you go, back over to quizzes. Sorry. So how many of the shortest possible paths are there? I'll give you like 15 more seconds just to look at this thing, I think. I can go this way, and I can go up on the last road. I can go this way. I can go up on the last road, then go over. So I think if you just count how many different ways you can go up without going backwards, that should give you it. What did I do? I skipped over my slide. Where's this going? Did it not do it? I didn't end the question. It just skipped the slide for some reason. I don't know why it skipped slides. Getting butterfingers up here, I guess. It should be 7. There should be 7 different ways. I think the last class, a lot of people counted 6. And I think they counted 6 because they didn't count like this end street or something. Maybe they counted 1, 2, 3, 4, 5, 6. But there's 6 blocks, but there's 7 streets. It's like one of those weird things. There's like 7 numbers, but there's like 8 spaces in between the numbers or something. It's always when you're counting, you have to either add 1 or subtract 1 sometimes. Include the endpoint or not include it, sort of thing. So this, we want to find the area in acres. So we're going to set this up a little bit first. So we want to find this. What do I need to find first before I find the area?
You need to find the that's width, so I guess the length.
Yeah, the leg there, right? We got to find the leg, a B or A, whichever one you want to make it. So we got to find this thing. Guess what I'm going to use to find this thing?
Pythagorean theorem.
Pythagorean theorem. All right, is this the one that I messed up? This might be messed up. Pythagorean theorem is that guy right there. So I want to plug in 200. Okay. 200 and 800 are the ones here. Okay, good. So they're giving me this picture from, this was from the notes or whatever. Now in the homework problem, they're giving me different numbers to plug in here. Now they're saying that this is 200. They're saying that this one is 800, but using the same picture, right? And so we're going to find this B over here, I guess is what I labeled it. We're going to find this with the Pythagorean theorem. So we got to do a little bit of solving for that. Then after we find B, we want to find the area of a triangle. So we talked a little bit about that, but it's a half base height. And then after we find the area, there's one other thing we got to do. And so the next slide, I'm going to ask you, this is the question for the next slide. We want to convert our square feet that we found from the area to acres. And so we're going from small to big, divide the pig. We should be dividing by this number. So 43,560. Write it down if you ain't got it. I'm going to hit the next slide. But we want to find this side. We want to find the area. And then we want to divide the area by 43,560 to get it into acres. Okay, so next slide, connect, refresh, whatever you got to do. Come on. All right, next slide, come on. think I fixed them. There's the new numbers in there. So first step is to find this side. The next step is to find the area. And then the last thing, whatever we get for square feet, we got to divide that by 43,560 to get to acres.
Wait, I'm sorry. How do you convert the feet into acres?
Divide by 43,560.
43. Yeah, thank you.
And again, we'll go like a little bit more into depth and how to do like whether we're supposed to multiply or divide and how to do units a little bit more when we get into the unit conversions. There's going to be a later chapter where we do that sort of stuff.
43,560 is in 43,560 or 43.56.
So 43,560.
Okay, perfect. Thank you.
And I'll give you all, 30 more seconds? Okay, so how many does it go over? 800 squared minus 200 squared, and then we have to take a root of that. So you should be getting somewhere around 775, I think, right? 774.6, I think is what, if I round it to 2 decimal places. I'm gonna multiply that by 100 or 200, divide it by 2 because it's a triangle. And I should be getting something like 77,460. If I divide that by 43,560, it should be giving me somewhere around 1.778 or around like 1.78 acres, I think is what it's going to be. Okay. 43,560, that was the conversion factor. The other thing would be like 77,460 if you didn't do the conversion, right? There we go. There's one that you got it. You just didn't do that last conversion. That's fine. All right, determine the lengths of the unknown sides in the following pairs of similar triangles. I think 60 seconds is probably pretty good for this one. These are similar triangles, so hopefully there are some sort of ratios you can write up here. The first thing is we want to determine this x. So figure out what number that x is going to be. And then the next thing we're going to figure out is what is that y going to be. So first thing, what is x? How does this relate to this? You could do ratios. This one, if I'm being honest, you could probably find an operation just to figure it out between the two of them. It's not the most complicated equivalent or similar triangle example. All right, so x should be, 4, I believe. And the next one is y. So figure out what y is, and then maybe I'll talk a little bit more about how we did it. This one. The easy way, I guess you could go what 10 to 5 as what 6 is to y if you wanted to do fractions or ratios. The other easy way is we're going from 10 to 5. That's the same thing as dividing by 2. So if we're dividing by 2 to get from 10 to 5, we're also going to divide by 2 on both of these numbers. So x should be 4, y should be 3, right? Here we go. Look, everyone got that right. Congratulations. Assume that the solar axis policy, so this is the sort of picture they give us in the book. Now they want to change around a few of the numbers. They say it's a 12-foot fence gives a 25-foot shadow, and there's 60-foot from the house to the fence or something like that. But the premise of this is we want to be able to get similar sort of triangles out of this. So if we're looking here, this angle is going to be the same. And this is a right angle, so this is the same angle. This is a right angle, and so this is the same angle, right, as this angle. So if we look, these two things should be similar triangles. Do we see, hopefully, the similar triangles? Like the height of the fence to its shadow and the height of the house to its shadow should be similar, right? So if we're doing the height of the fence here, this is what, 12 to 20. Should be the same as the height of the house here, which I have as h to its shadow, which is 50. So sometimes they'll do this with like measuring the height of a building. Like they'll measure the person's height and then measure the height of the building according to how the shadow casts itself. But this is like their homeowners association. They don't want your house to basically be casting a shadow past your fence, right? You don't want your shadow to be casting on your neighbor's house, I guess is what they want. They want you to leave enough space. They don't want you to build your house too big. So we need to figure out how big can we build our house. So hopefully you're setting up some equivalent sort of ratios in there. I got the numbers replaced with what they give us in the problem. So the fence has a 25-foot shadow. There's 60 foot from the house. There's a little bit, maybe a little bit of calculating that I did for you. 60 and 25 gives you 85. But set up equivalent ratios, figure it out, figure out the height of the house. Okay, I'll give you a few more seconds, 30 seconds, something like that. And so hopefully the first fraction you have on there, I hope you put the fraction 12 over 25. And hopefully try to say that that is equal or going to be proportional to what, h over 85. And if you do that, ooh, what happened to that one? It didn't end the question. If you do that, there's a little bit of cross multiplying. You're going to multiply what, 12 by 85, and then you're going to divide it by 25. You should be getting something like 40.8, I think is what it should be. Looks like you are getting it. 40.8. Some people are getting it. What are y'all doing? Are you doing fractions in that? What was that? 204 over 5? If someone did 204 over 5, I'm gonna 40.8, 42.5. Should be 40.8. All right, so if we do maximizing area, so I know it's 420 right now, so if you got to get going places. But if we want to do maximizing area, if we think about a rectangle, our perimeter is going to be 2 of the width and 2 of the lengths, and our area will be equal to length and width. So if we want to give a set perimeter, and I think this is probably maybe the easiest way to think about it, we have 2L and we have 2W. If we have a set perimeter, I don't know, give me what, 10 feet of fence. So let's say we have to construct something with 10 feet of fence. I know that this is one of my formulas. I know my other one looks like length times width, whatever the heck those things are. This one, my perimeter, I can do a little bit of solving on. So I think it really doesn't matter which one I solve for, but if I want to solve for my length, I'm going to subtract the 2W over. Let me get this out of here. And then I'm going to divide everything by 2 to solve for L. So let me do that in one step here. And so what is happening here? I end up getting this like quadratic. And so what the computer is doing basically is they're seeing the substitution for L. They're saying that my L is really 5W. And they're replacing the L with like the 5 minus W. So I know I have a set perimeter. I can figure out my area with a set perimeter. And so what is going to maximize my area? It's going to be when my width is 2.5. Well, if that's the case, then my length is also 2.5. And you might notice if my width and my length are both 2.5, what this is telling me basically is a square is maximizing my area. So this is as high as my area is going to go. And my area is going to be the most when I have a square. So the thing that maximizes a rectangular object is a square. So square maximizes rectangular prisms. An equilateral triangle would like maximize triangles. If you want all 2D figures, it would be a circle. Circles maximizes your area for a 2D figure given a set perimeter. So given like set amount of material to build something out of, if you got to do it rectangular, try to do it as square as possible. Is basically kind of the lesson here, right? And if you want to add a dimension, what sort of rectangular 3D figure do you think would maximize volumes for rectangular prisms? It would be a cube, right? So what you're saying, hopefully? Yeah, same sort of figure, right? We can plug in the surface area into the volume, and we can get a sort of same mathematical demonstration as to like what's going to maximize that formula, right? It will be at a vertex somewhere, probably. Same way that previous one looked, right? And so this is, suppose you are designing a cardboard box, and it must have a volume of 8 cubic feet. So right away, what he's doing is stupid, I think, right? Is that what they're saying? Or is this a different one? Oh, no, this is a different one. So the cost of the cardboard is 15 cents per square foot. What is the most economical design for the box? We talked about that. It's going to be a cube, right? So we want to make it even as possible. And if we do that, how much will the material cost? So I think the first thing is we know it's got to be a cube. So if the volume is 8 cubic feet, what is each side going to be? What is the length of one side? And after you know the length of one side, what is the surface area of this thing going to be? It's a cube. So the side would be 2, right? Would be 2 feet. Each side would be 2 feet. what's the area of one face? I think that's the easiest way, right? What is the area of one face? And then how many total faces are there in a cube? Top, bottom, front, back, left and right. And that'll give you the amount of feet. And then there's like one last little thing. If it's 15 cents per square foot or something like that, how much is the total cost? Whew, there are a few steps in this one. Huh? So your final solution should be a money amount, I believe. All right, so I'll give y'all a few more, 30 more seconds. I think. Okay, so each dimension is going to be 2 feet. The length of it, or the side, the length of one side is going to be 2 feet. One of the faces is going to be 2 by 2 feet. It's going to be 4 square feet. So one face is 4 square feet. 6 faces is giving me 6 times 4 is going to be 24 square feet. If I multiply 24 square feet by 15 cents per square foot, I should be getting $3.60. $3.60. All right. So let's go on. We have just a few more. I have one that's really broken up. This one's really broken up, and then I think there's like one more quick one after this, or maybe 2 more quick ones. But this one is really broken up, and probably the last like difficult one, or one of the more difficult ones on here. So the first thing, we have this sidewalk, and it says something about build sidewalks last. So let people plan where they want to walk, and then build a sidewalk. But we have this thing here, and we want to break it up, and we're probably using that theory we got from that cult a while back. But this is the first thing I want to find. I think this one is the most straightforward portion of the sidewalk to find. We want to find the length here. So that's my first question. Okay, so I'm going to look at this picture, and then I'll count to 30 or so. This one shouldn't take you hopefully too terribly long. The dimensions for this one are already there. The other ones, we're going to have to look at the dimensions and try to figure them out. I think I even said something wrong in one of them, maybe. Okay. Round to 2 decimal places. I think you'll be fine if you round to 2 decimal places. Are we getting this one? So this is Pythagorean. These are 2 legs. A squared plus B squared should give me C squared. So I believe I got to do 15 squared plus 15 squared and then do the square root of that. And if I do that correctly, I did it without ending the question, huh? If I do that correctly, it should give me something like, where am I at? 21.21, something like that. And again, we're talking about this sidewalk is 21.21 meters. Okay, half of there. The left side. So if we want this left side, how am I figuring out this left side? This distance right here.
Well, it's a rectangle and the other side is 40 and there's already 15 meters occupied. So it'd be 25 meters, I guess.
That's it. So that's what you want to do with these things. You're looking at the whole dimension, and then this little part will be 40 minus 15 will be 25. If we look at this dimension, right? We got 30 here and we got 15 here. I believe that's going to give you 15. And so now we want to find this guy's hypotenuse. And the next one should say 25 and 15. I think I might have messed up with the number. That should definitely say 25. Sorry. 1 minute's good. Like, you should be able to get these things down in about a minute. And again, that should say 25, not 20. Whoa. What? That was a wheezy laugh. Apparently I submitted. I don't know what I submitted, but I submitted something. Oh, come on. It should have been 29.15, right? Okay. So 25 squared plus 15 squared, and then we take a square root of that. We're using the Pythagorean theorem. Same thing here. We want to figure out this thing. This thing might be a little tricky because you have to maybe like bring this thing down. We want to create a right triangle somehow with this sidewalk. And the easiest sort of way to do that, I think, is just to make your right angle here, right? So now we have a right triangle with this sidewalk. If we're looking at the top, I think that part's the easy part. It's just this 30 meters that we're looking across here. The other part, this right side over here, we got 15 and 50 here, and we got 40 here. So you got to take a difference there somehow. Are we there? Which is what?
Ten.
10? Yeah, you're saying 10. Okay, that's it. Making sure we're there. We're there. Let's do it. Next problem. So we got one that's 10. We got one that's 30. Guess what we got to do to figure out that missing side? Got to do some Pythagoras. Round it to 2 decimal places. Do some Pythagorean theorem. Oh man, y'all quicker than me. And they're talking about meters. We should be talking about meters too. Although I don't think I'm really particular quite about the units. When we get to unit analysis, I will be more picky on that kind of stuff. All right, 15 seconds. What? Yeah, there are 2 really quick ones after this problem. All right, so I think most people are getting it that submitted something. All right. A rancher must design a rectangular corral with an area of 400 square meters. She decides to make a corral that measures something stupid. It's not a square, whatever she wants to say. That is not the way to maximize that. How much fencing is needed for this corral? Has the rancher found the most economical solution? No. So how much fencing is needed for what she wants to do, I guess, is the first question. And then what is the most economical solution? And then how much, oh shoot. I didn't mean to hit that. And then what is the most economical solution? And what would the dimensions of the economical solution be? Oh, I can resubmit it. Oh, that's cool. You can go back in and hit, I meant to hit like Shift Enter or something, but you can't do that on your phone, huh? And so if they do it with a square, what would it be? That's the other question, right? 400.
We're just, on this answer, we're just doing the how much fencing we need on the first answer.
Yeah, so how much fencing would you need if you did it the stupid way that she did it? And then how much fencing would you need if you did it the smart way, building it the cheapest way, right? And so there should be two different things. Like so many, shoot, I said meters and then I said feet in my solution. It should be so many meters and then so many meters. The funky meters. Y'all know about the funky meters? The Neville brothers. It was an old funk. New Orleans funk. Art Neville, Aaron Neville had his own successful little career, mostly in the 80s, I think. Early 90s. I want to say like the meters are from like 60s, 70s. They're like old funk. They went by the meters and then they called themselves the funky meters for a while, for a minute. Quiz, reload the quizzes. I don't know what to say. Try to reload it. Fio on the bio. Come on. 7 people. So doing it, yeah, it should be either 100 meters or 80 meters, depending how they're doing it. So doing it her way is going to be 100 meters. Doing it the smart way. So we have an area of 400. So if we have an area of 400, what is the dimension of the length of the square? That probably sounds weird. If the area is 400, what is the length of a square with an area of 400? How do you figure that out? 20, you square root it. Okay, so a square maximizes the area. Therefore, oh, here's a breakdown. Sorry. Forgot the breakdown slide was in there. So for a set area of like 400, we want to know what the side of a square would be. We'd have to square root it to figure out it's 20. If each side is 20, we have 4 of those sides going to give us 80 feet of fence. And then there's one last question. Oh man, I don't like this question too much in this class, to be honest. They should put this after they do the unit analysis. But the basic question says that we're in a truck that's a water truck and we have a 40-ton limit. It gives us the weight of the water per square cubic foot. Sorry. It gives us the weight of the truck. It gives us the weight of the tank. And so they want us to figure out how much the whole thing weighs. And so the first thing is we want to figure out like the weight of the water. So maybe one thing that you might have to do is convert your feet to inches. So they give us the dimension of the truck in feet. Convert that to inches. You multiply by 12. You multiply by 12 and then add 6 more. But we want to know the volume of this thing. In order to find the weight, we got to find the volume. We know the weight per the volume, per the cubic inch of volume. So we want to find the volume of the cylinder. So that's what I'm plugging in there. That's our volume of the empty cylinder. We know that this is how many cubic inches it is. We know that water weighs this many pounds per cubic inch. And we know our truck is full of water. So we're saying our truck, the water in the truck is going to weigh this many pounds. Okay, we know the water in the truck weighs that many pounds. We want to know how many tons that is. I believe there's 2,000 pounds in 1 ton. Is that what we're doing next? Oh, never mind. No, sorry, we're adding the weight of the empty tank. Now I think the next thing we're converting to tons. And so with the tank and with the tank and the water, it's going to be like 91.97 tons. And so I forgot the weight of the truck. It's like so many tons, but you're definitely not going over that bridge. And if you add the truck, you're still not going over that bridge. It's going to be even worse. I think you're doing almost.
No, just stop now. It's
yeah,
no.
It's not happening. Don't do that. So don't go over that bridge. Any questions over anything? You got a test coming up next Monday. There is a quiz that is due before your test. Turn that thing in. And I sent out an email, so hopefully you read that. Like, there is a quizzes that you can